So we're going to start by looking at radians. So radians is just another way of measuring angle. So sort of think about some angles. So if I just start with, is it pretty good? It's obvious what that's supposed to be. It is a circle, awesome. If I label it circle, it actually is a circle. If it doesn't look like a circle, it's your eyes that are the problem. It's labelled, therefore it is. This is a circle. Okay, and if I just say we've got something to refer to, if I say it has a radius of 1 metre, 1 millimetre, whatever it is, doesn't matter, just 1. So the circle is 1. Okay, so some things about angles. If we start measuring some angles, so if we measure that angle, how big is that angle? 90 degrees. And how big is that angle? 180. And how big is the angle if I go all the way around to where I started from? 360, okay, so we'll circle right round to there. Whoa, lasted 5 seconds and Jaden's out. It's trigonometry, it's all over. Okay, so we've got these angles. So 360 degrees is a whole circle, 180 is half a circle, 90 degrees is a quarter of a circle. Those of you that are into skateboards will be able to tell me all about 720 and 1060 and all the rest of them. There's numbers that you know because they make sense. 540, double backflip, etc. It all makes sense. These numbers make sense because they fit into the idea of 360. But the question is, why 360? What's magic about that number? Why are we using 360? It's pretty much exactly. Some dude decided one day that we'd go with 360, and we've sort of stuck with it. Harrison's got a suggestion here. The circumference of the Earth. It does sound good, doesn't it? We should go for that. I'm not sure, actually. I might do a bit of a history lesson. We should Google that. Okay, but circumference is a really, really good idea. So let's think about circumference. If I start from here and go all the way around the outside of the circle, not worrying about angle at the moment, just length, how long is that blue line? Circumference. You mentioned circumference, Harrison. So how long is that blue line? Come again? 2 times the diameter is not quite right. You're on the right track, though. R squared is going to give you the area of the circle, so not the area. Come on, guys, what's the circumference of a circle? No, pi r squared is the area. Anything with a squared in it is going to be area, so forget the squared, okay? As soon as you go squared, you go metres by metres, so you've got area. Close. 2 pi r. 2 pi r or pi d. Okay? Okay, so if I go from here all the way around there, it's circumference for inch is 2 pi r, which in this case is going to be 2 pi because r is equal to 1. Okay, so if I go all the way around that circle, I've gone 2 pi metres, millimetres, whatever it is that I'm measuring. This must be a brand new pen. It's dribbling on the board. Yeah, perfectionist. Okay, so we have the circumference is 2 pi. We could use that to measure the angle. So we could say if I start here and I go all the way around, either you can think of that as you're going around this much angle, or you could think of it as you're going right around that much length. But it would make sense to say, going once round, I've gone 2 pi. Yep, so just as much as I say this is 360 degrees, I could say at the outside, I've moved 2 pi. I'll give you the same information, yeah? I'm getting a few confused looks here. Okay, so if I'm saying I'm standing here and I want to do a full circle, I can either say go 360 degrees, in which case you'll go, oh yeah, 360 degrees, once around, I'm done. Or I could say go around the outside until you've walked 2 pi metres. So just go around 2 pi, and you'll be back to here. Yeah? So what, say I gave you the instructions that said just go pi. How far would you end up going? 180. Yep. So I said just go pi, you'd start here, and you'd stop at 180 degrees, wouldn't you? You'd go half the circle. Half of 2 pi is pi, you've done half the circle. What's that I said you go a half of pi, where would you end up? So starting here, and I only want you to go half a pi, where would you end up? 90, you end up at the top, wouldn't you? Okay. That's what radians are. Radians is just saying how far you're walking around the outside of a circle of radius 1. Okay. And that's tied in just to the actual circle. There's none of this arbitrary 360 number. It's actually to do with the length of the circle. Okay, so radians is a measure of how far you're going around, which is just what an angle is, but it's compared to the actual circumference of a circle rather than an arbitrary 360. Okay? And that turns out to be really, really useful when you're looking at sines and cosines, which I'll explain in a second, have to do with how far you're moving on a circle. Okay? So you don't end up with this funny numbers like 90 or 135 or 540, which have actually got nothing to do with the circle. Whereas if you deal with 2 pi, it has actually got to do with the circle. Okay, so if we just have some basic ones that you should really be familiar with, degrees and radians. Okay, so 0 degrees is 0 radians. Looking at your basic ones, 90, 180, 270, 360. You really need to know these ones. You've got to be familiar with, and any other ones inside are a bonus, but these ones you do need to know. Yeah, so we're just looking at the circle idea, what numbers we're going to put down here, and then we'll come up with a formula for going, or a process from going weird, because if I gave you 57 degrees, it's kind of hard to figure out exactly what fraction it is, but we should be able to transfer anyway. So what numbers am I going to put down here? Which is the easy one to start with? Which is, now what number, if you want to start with 90, what do you want to write here? I want it in terms of pi. Pi over 2 for 90? Half of pi. Okay, the easy one to start with is usually, yeah, I want it in terms of pi though. I don't want a number. It's a decimal radians. This is pi radians. Okay, so 360 is 2 pi. Yeah, so right around the whole circle is 2 pi around the outside. So 180 is half of that, which is pi. 90 is half of that, so half of a pi. So what's 270 going to be? 3 pi over 2, so 1.5 pi's. Okay. Those things you really do need to know in terms of pi. You can, as Sharina was doing, you can make a decimal radians. Okay, which is where you just actually work these numbers out as decimals. So pi is 3.14, 2 pi is 6.28, half of pi is 1.57, and this is 4.71, I think. Okay, so the radians are just numbers, because pi is just a number. Kind of a fun number, but it's just a number. So you can express it as a decimal, but actually it's not exactly 3.14. Pi has got a few more digits than that. Yeah, some of you can go to about 6 or 7, but you keep on going. Yeah, so as soon as you put a decimal, you've chopped some of it off. You're losing some of the precision, whereas this is exact. Pi is exact. Okay, so the question of how do I go for a general one? So if I've got some weird number like 57 degrees, how do I get that as in radians? And to be perfectly honest, it's very hard to get it, well, it's not hard, but you get it with weird fractions. To do it as a fractional radian, often it's easier just to go straight to a decimal radian. So basically, if we're trying to go from degrees into radians, we need to divide by 180 and multiply by pi. Yep, and if we're going the other way, just do the opposite. So we divide by pi and multiply by 180. .180 in pi is because that's where the turn-off point, pi equals 180. You could pick any pair of things off this table and put them in there and they'd work fine. But the usual one that people play with is 180 in pi. So what's 57 degrees in radians? 0.99? Okay, so we do 120 degrees. So in the exam questions, sometimes it'll say express your answer in terms of pi, so it wants this answer. Sometimes it'll say decimal, so it wants this answer. Sometimes it'll do both. Question? Can you calculate it? Yes, as long as you don't worry about the pi, but I'll show you. Yep. So if we start with 120 degrees and we want to put that into the pi radians, so we've got 120 degrees. To change into radians, we're multiplying by pi and dividing by 180. Yep, so there's the pi piece. So all you need to do is put 120 over 180 as a simple fraction. So what's the simplest form of that fraction? Yeah, so you can divide them both by 60, so it's 2/3 of pi. Yeah, so ignore, it's used on the calculator, ignore the pi bit, put that in as a fraction, and just ask for the simplest fraction. The calculator will do that, it'll give you 2/3. So this one is 2/3 of pi. Which again, if you wanted to, you could do as a decimal. You'd come up with something horrible. Someone's pushing the buttons for me. Can't be 0.66. 2.1? Is that 2.10 or? That's right. So you don't have anything else, 2 decimal places, you might as well stick with 2 decimal places. Yeah. So if you get a question in the exam or in your assignment, if you have a look at question 3A on your assignment, it says 30 degrees, which you'll notice I've actually managed to avoid doing on the board. But it's exactly the same process. So just do exactly the same as this. Start with 30 degrees, times pi over 180, simplify the fraction to get it in terms of pi, and then just calculate that as a number. I'll give you 5 seconds, and I expect you will have done question 3A on your assignment in that time. Now, seriously, any questions about that? So the idea that radians is another way of measuring angles, it's associated with how far around the circle you've gone, and you need to be able to change from degrees and radians. And as you go on, you'll use radians a lot more and degrees a lot less. Anything which you're going to deal with in terms of cyclic motions, shafts turning, all those sort of things. If you're doing electrical stuff, all of your waveforms are all radians make a lot more sense than degrees when it comes to playing with them. Question, Shane. Sure. So do you want to go radians to degrees? So if we had something from this column or this column, doesn't make any. This one? Okay, so let's go, say we had pi over 4 radians, and we wanted to put it into degrees. So pi over 4 divided by pi times 180. So times 180 divided by pi. Pi's cancel out. And we're just left with 180 divided by 4. That's last time I looked was 45. Yep. So pi over 4 is 45 radians. If you were starting from this column, you wouldn't be able to, you'd have a number here rather than cancelling out the pi's. So you just bung into your calculator, whatever times 180 divided by pi, get a number for it. Re. Oh, yep. Correct. Yes. Yeah, so the pi here is because of that pi, and then this fraction is just that fraction. Any other queries on what's on the board at the moment before we disappear and start looking at sine and cosine curves? Right, okay, so all I've done at the moment is just introduce radians, said this is another way of measuring angle. Okay, so we're going to measure angles. Rightio, let's rub this off, and I want to introduce you to a sine curve and a cosine curve. And then we're going to, and explain what they are. I mean, why, you've probably used them before. Yeah, when you've solved triangles, you've used sine and cosine. They've got a lot more uses than just solving triangles. Like anything that's got to do with things that go around, basically, or things that repeat a lot, sines and cosines are going to be the things that we use to model them. So this is, again, the idea of maths being able to model what's happening in the real world. So we've talked about parabolas. So if you want to look at things going as they fall in the air, you need to know about parabolas. So you need to know about x squared type equations. If you want to worry about things that are going round and round and round in circles, and you want to ask the question of, so it's going around in a circle lots of times, and you want to ask the question of when is it at this height? There and there and there and there and there and there, yeah? Somehow you've got to figure out something that repeats lots of times, and you can ask questions about what height it's at. If you're going to do that, you're basically going to be looking at the situation here. So here's our circle. It's going to go around, and because we have to have some starting point, we're going to start here, and we're going to go around that way, just like I did before. Okay, so that line is now at 0. 0 radians, 0 degrees, it doesn't matter, it's at the start. And it's going to go around this way. Okay. And I want to ask the question, when is it that high? Okay, so you've got something going around, and you want to know when it's at a particular height. Okay. This works for tides, for example. Don't go round, but they go up and down. Yeah. So what we really want to do is, when we've moved to this point, it'd be really, really nice if we had some way of figuring out how high we were. And while we're at it, we might as well figure out how far along we've gone. Okay, so as we go around, it'd be good if we could say, how high are we and how far along are we? Those two questions would be really, really useful. Yep. This is what sine and cosine are. So all cosine is just answering the question, how high are we? And sine is answering the question, how far along are we? And those of you that are onto it will have realised I'll just write that back to front. Sine is how high up we are, and cosine is how far along we are. And that's a really bad start. It was wickedly bad. Okay, so as your circle goes around, how high up you are is the sine, and how far along you are is the cosine. Which, if you look at this triangle, that's how far I've gone. In terms of triangles, what's this side of the triangle called? Opposite. And what goes with opposite? That's the hypotenuse, that's the opposite, that's the adjacent. And remember SOHCAHTOA? This is where SOHCAHTOA comes from. So is sine is opposite over hypotenuse. Okay, so the opposite is the sine. The hypotenuse here is just 1, because it's exactly the same circle I had before. It's got a radius of 1, so the hypotenuse is 1. So if the hypotenuse is 1, then the opposite is just the sine. Yep. So this length here is the sine. This length here is the cosine. Okay, so have a look at that for a second, ask a couple of questions, and then I'm going to show you how that magically turns into a sine curve. Rightio. Okay, so here we go. All I'm going to do is I'm going to go, I want you to go watch the tip of the pen as I move it around, and I want to focus on how much it's going up and down. Okay, so here we go. So we're going around. Yep. So if all you're thinking about is the up and down motion, then if we were looking at it end on, so I twist the thing around so it was sideways, all you'd see would be that, wouldn't it? Yep. So don't worry about how far it's going that way, just the going around, it goes up, top, down, bottom. Yep, so it goes up, top, down, bottom, it just does that. Yep. Okay, what I'm going to do now is draw a graph. So here we go. So that's the top, which is at 1, because the length's 1, and that's the bottom, which is at -1. And I'm going to let time happen. So all I'm going to do is move the thing up and down, but instead of going up and down in exactly the same place, as time goes, I'm just going to move along for time. Okay, so the time, so I don't think I'm just drawing my line up and down at the same place. I want to move along for time. So here we go. So it's going up and down, and then I'm going to start walking normal time. So here we go, going up and down and walking for time. Okay, that's a sine curve. So it just tells you how far up or down the pen was at a particular time. It could be continued to infinity, but I bumped into the desk and I got out of view of the camera, and Emma would have yelled at me. Yep. So there is a limit. Yep. So you're exactly right. It goes on to infinity and beyond. Yeah. So it comes back this way as well. Thank you. Someone there. Toy Story. Yeah. Okay. So you can go either way to infinity in both directions. Yep. Definitely. So the answer to when is it this high is here and here and here and here and here. Yep, there's an infinite number of solutions to when is it this high, which is what you expect if something's going round and round and round and round. It keeps on getting to that height every time it goes around. Okay, I'm just going to take the time off there for a second and call it angle just for a second. We'll go. Often you do these things time-based because you're looking at things going round in time. But if we start thinking about how far the angle's gone at each of these points. So here, the angle was 0, wasn't it? That's where we started. We started at 0. This point here, what's the angle at that point? How far have I gone along before I get to that height? 90 degrees? Good. Or those of you that have caught up with the play will tell me that that is half pi radians. Awesome, well done. Okay, so pi over 2 radians. Yep. What about this point here where it gets back to 0 for the first time? 180. Okay, so it's gone right round and gone back to 0. So that's 180 or pi. Awesome. Enjoying this. What about this point here? Yep. Or 2 pi. And what about this point where it's at the bottom? 270 degrees or 3 pi over 2, 1.5 pi's. Awesome. Etc. Carries on from there. You must be able to sketch that graph and put those points on it. Okay, this is one of the things you just need to learn how to do. It makes sense when you see where it comes from, but you need to be able to, you don't have to go past 360 much. Okay? You need to be able to draw that and know that it carries on if you need to make it carry on. You have to be able to do that. Okay? If you can't do that, you're going to be really struggling when it comes to solving any trig equations. We're just trying to work out how high something is or how far along it is. You've got to be able to draw that curve. Yep. So that's the curve. That's the sine curve. This is x, and this is y. That's y equals sine x. Okay? So that's answering the question, how far up am I? So straight away, if I've gone around 45 degrees, so if I've gone around 45 degrees, so I put 45 degrees on here, how far up am I? How far up am I if I've gone around 45 degrees? What does it look like on my picture, roughly? So about 0.75, about 3/4 up. Okay, can anyone give me exactly what it is? How far up exactly is it? Use your calculator. What have I just been telling you? What are we doing here? What's this curve? I mean, what's this curve? Sine 45, exactly. Just do, on your calculator, just do sine 45, and it'll tell you 0.71, I think. Yep. Okay, hang on. So we can do. So what are you saying? 0.85 and 0.70, 707, isn't it? So 71 if we round it. Okay, rightio. So we've got two answers. You can't have two answers to one maths question. What's going on? Okay, exactly. So if you've done 45 radians, the answer is 0.85. Where is 45 radians on my graph? Well, it would be. This is 2 pi is about 6 radians. So 12 radians, 18 radians. So 45 radians is way off, exit screen left somewhere. 45 radians is way the hell down there somewhere. But if we went and drew it all the way and put the wee line up at 45 radians, it would have come back at 0.85. Okay? So you've got to be really careful when you're using your calculator. Are you thinking about the angle in degrees or in radians? Okay. And because I put 45 degrees there, you have to have your calculator set in degrees and then do sine of 45, and the answer will come out to be 0.71. Okay? So you've got to be really, this is where it matters whether your calculator's in degrees or radians. It makes a huge difference. Okay? So let's say we had one along here somewhere where we did, what's this going to be? This can be 6 pi over 5. That's just a wee bit bigger than 1 pi. So if we did 6 pi over 5, should put it a bit closer into here somewhere. What's that going to be? If we did 6 pi over 5, what's the answer going to come out to be? Okay, so you get a few frowning looks from here, so people aren't confident with your answer. No? Negative 0.50. 587, so we'll call it 59. Well, it looks pretty good. I mean, it's negative for a start. It's sort of in the middle, so it looks pretty good. The other people get the same. Anybody else confirm the same thing? Chris has got the same. Okay, so two things you're going to have to do here. First thing, degrees or radians. How do you change it? This is where you've got to get the driver's license manual for your own calculator out and figure out how to do it. Different calculators do it differently. So we'll probably, in a minute, we'll pause and we'll just take a second to make sure everyone can do that change on your own calculator. Okay? So calculator has to be in radians, and also when you put the thing in the calculator, you're going to have to do brackets. If you don't bracket it, it'll turn to custard. So sine, open bracket, I know 6 times pi divided by 5, close, any combination of that will be fine.